Good morning. Now, in structural analysis, since last three lectures, we have understand about the influence lines for indeterminate structure and determinate structure. Indeterminate structure, we have solved lots of problems, and in indeterminate structure, we have just understand about the proper cantilever beam. Now, the influence line for continuous beam means it is two span continuous beam. So the basic concept of the influence line is always same. Now for the understanding, here I have taken one small example, and that is draw influence lines for a reaction VA, VB and VC for two span continuous beam shown in the figure. Compute ordinates at 2-meter intervals. So here we have total span to AB and BC with length of AB 8 meter and BC is 4 meter, and every 2 meter we have to draw influence line and ordinates. Now how it is calculated, just like this is our beam of simply supported, and first of all we have to find the reactions for a unit load at B. So reaction for V is equal to 0.33 and here 0.66. Remove support at B and applied unit load at B. It will create a conjugate beam. And for this conjugate beam, we have to finding out the reaction again. And after this conjugate beam, we can finding out the reaction for the different supports. So this is our conjugate beam for this unit load, and reaction for that is 7.1 kilonewton into meter square upon Ei, and here 8.9, and this is calculated somewhere over here. Reaction for the conjugate beam Vc dash into 12 is equal to 1/2 into 8 into 2.66. This is into 2/3 of 8. Here we are going to take moment at A point plus this much 1/2 into 4 into 2.66 into 8 plus 1/3 of 4. So we can calculate Vc dash over here, and it is the reaction of conjugate beam. Now Vc dash is equal to 8.86, so we can take 8.89 somewhere over here, and Va dash we can calculate 70.11 kilonewton into meter square. Now from this we can calculate the reaction Vb, and that we know we have the equation from the Muller-Breslau principle, that is Vb is equal to delta Xb upon delta Bb. Now for the conjugate beam, deflection at any point is equal to bending moment at that point, that we know. So delta 0 is equal to 0. Delta 1 is equal to 7.1 into 2 minus 1/2 into 2 into 0.67 into 1/3 of 2 is equal to 13.75. Here we are going to finding out ordinates at 2-meter interval. So here the gap of that 2 meter, and here ordinates of that intervals, and here again it is something like this. So we can finding out the delta for the different position. Now let's see what is done over here. We have now delta up to 6 position, but delta BB where we have taken the unit load at point at position number 4. So delta 4 is equal to our delta BB. So VB is equal to delta XB upon delta BB. Now the influence line ordinates for the VB that we can finding out delta XB upon delta BB when X is equal to 0, delta B is equal to 0 upon the delta 1. So delta 0 is equal to 0. At X is equal to 2, delta BB at 2, 13.75, and delta BB that we have 28 point. So we will get 0.483. Now X is equal to 4. So VB is equal to 24.84 and it is 28.59. So we will get this. X is equal to 6, X is equal to 8. We can finding out the all VB from that delta XB and delta BB. At a X meter it is 1, at 10 meter it is 0.594, X is equal to 10, and again it is 0. Now the VB is over now, but what next? We have to finding out the VA and VC again. So for that we have to taking moment at C, so we can calculate VA. So VA into 12 plus VB into 4 minus 1 into 12 minus X. So this equation is important for us and we have that VB. So we have to put this value in this equation. So we will get the influence line ordinates for VA. So at X is equal to 0, VA is equal to 1. At X is equal to 2, VA is equal to 0.672. At X is equal to 4, VA is equal to 0.376. At X is equal to 6, VA is equal to 0.142. We will get this much VA. Now we have VB, now we have VA, and third reaction, that is VC. So again for that we have to take the moment at A point, so we can calculate the C. So influence line for VC, that is taking moment at A, so VB into 8 plus VC into 12 is equal to 1 into X. So here we have equation for VC in the form of VB. Now we have VB. So we can put that value of VB and we will get the ordinates for influence lines at VC for a distance X is equal to 0, VC is equal to 0, X is equal to 2, VC is equal to minus 0.155, X is equal to 4, VC is equal to minus 0.248, X is equal to 6, VC is equal to minus 0.216. Simply just put all the values in this equation and we will get the influence ordinates for VC. Now we have all these ordinates of influence at 2-meter intervals for our continuous beam. From these influence ordinates we can plot our influence lines diagram on the basis of this. So first, influence line for VB. So whenever we have VB, influence line for VB, so it is 1 over here. With reference to these ordinates will be plotted over here, and we can draw this influence line diagram for the VB in the form of curvature. So at 0 it is 0, at 1 it is 0.483, at 2 this is 0.876, at 3 1.074, at B it is 1, at 5 it is, and at C it is 0. So this is our influence line diagram for VB. Now after getting this VB, again draw the influence line diagram for VA. So for VA, here it is 1. At first position, it is 0.674. At 2 position, 0.376. At 3 position, at B it is 0, and at C it is 0. Here it is minus. So we can plot this influence line diagram in the form of curvature. So this is VA. Simply the same thing here. At VB, then diagram is 1. At VA, then here it is 1. At C point it is 1. So it is something like this. So at C it is 1, and in the form of it is reduced somewhere over here. So this is the simple method for finding out the influence line diagram for the reaction at support. We can calculate the whole influence line diagram coordinates, and we can plot the diagrams. This is the question of 7 mark, and it is very much important for you. This is our last chapter. From this 5 chapter, you can write up to 60 marks in a GTU exam. Again, here take same example, but what we are going to finding over here, that is, draw the influence line for shear force and bending moment at a section D, 4 meter from A, for a 2-span continuous beam shown in the figure. This is our 2-span continuous, same example, but here we have to finding out the shear and bending moment at a section D. It is somewhere over here. So what we are going to do? The same thing. First of all, we have to finding out the all ordinates for VA, VB, VC for these 3 support. From that we can calculate the, so first of all we have to finding out the reaction first. सपोर्ट बी को रिमूव करो, कॉन्जुगेट बीम बनाओ, उसमें से इन्फ्लुएंस लाइन फॉर वी बी, वी ए एंड वी सी फाइंड करो. नाउ वी आर हैविंग द इन्फ्लुएंस ऑर्डिनेट्स फॉर वी बी, वी ए एंड वी सी. After that we can calculate the influence line for VD. So when the unit load is in position AD, the shear force at D, VD is equal to VA minus 1. This is the simple calculation. So x is equal to 0, VD is equal to 1 minus 1, then it is 0. X is equal to 2, it is here. X is equal to 4, it is minus over here. But when our unit load in the position of DC, then the shear force at D is equal to VD is equal to VA. So we can calculate it directly. Now the x is equal to 4, VD is equal to this much, x is equal to 6, 0.141, x is equal to 8, it is 0, x is equal to 10, VD is equal to minus 0.031, and it is 0. So now we have all the values regarding the shear for this section. Now influence line for MD. So when unit load in position of AD, the moment at D is equal to VA into 4 minus 1 into 4 minus x. So x is equal to 0, MD is equal to 0 over here. Put all the values VA in this equation. So x is equal to 2, MD is equal to 0.688. X is equal to 4, MD is equal to 1.504. When unit load in position DC, then MD is equal to VA into 4. There is no unit load. So At x is equal to 4, MD is equal to 0.376 into 4, and we will get 1.05. X is equal to 6, MD is equal to 0.568, x is equal to 8, it is 0, x is equal to 10, it is minus, and x is equal to 12, again it is 0. Now we have all the points and all the values, so we can plot the influence line diagram for the shear. So what is happening over here? At 2 it is 0.328 minus, at 4 it is 0.624 minus, at D it is plus, at somewhere here it is 0.142, it is 0, it is minus, and here it is 0. So this is our influence line diagram for the shear VD. Clear? Now for the diagram of bending, we have the value, and that is somewhere over here, and plot it like this. So this is our cases of influence line diagram for indeterminate structure. Now here we have complete our total 5 chapters, and as we discussed, from 5 chapters you can calculate all the examples from that. Now no need to do anything more. So whenever we have a time, and if you insist, then we can move on the next chapter, but till then it is more than sufficient. So you can do all the example and calculate whole SA2 from here. This is very much important for you for the designing of structures that we have used in our next subjects. So in the first chapter we will study the whole building structure design in next subject. So dear student, हमने अभी तक जो भी पढ़ा है ऐसे 2 में, उसमें फर्स्ट चैप्टर था हमारा एनर्जी प्रिंसिपल। उसमें हमने कास्टिग्लियानोस फर्स्ट थ्योरम पढ़ा, कास्टिग्लियानोस सेकंड थ्योरम पढ़ा। फर्स्ट थ्योरम में हमने डिफ्लेक्शंस फाइंड किए फॉर द डिटर्मिनेट स्ट्रक्चर लाइक कैंटिलीवर बीम, कंटिन्यूअस सिंपली सपोर्टेड बीम एंड ओवरहैंग बीम। इन सेकंड थ्योरम हमने इनडिटर्मिनेट स्ट्रक्चर्स के लिए एनालिसिस किया, शियर फोर्स एंड बेंडिंग मोमेंट फाइंड किया विद द हेल्प ऑफ कास्टिग्लियानोस फर्स्ट थ्योरम। उसमें हमने फ्रेम भी सॉल्व की, सारी चीज़ें हमने सॉल्व आउट की। इन सेकंड चैप्टर उसमें हमने स्लोप डिफ्लेक्शन मेथड पढ़ा, जो स्पेशली फॉर कंटिन्यूअस बीम एंड फ्रेम के लिए है। उसमें भी हमने एनालाइज किया, उसके डायग्राम्स बनाए। फिर हमने मोमेंट डिस्ट्रीब्यूशन मेथड देखा, उसमें भी हमने कंटिन्यूअस बीम सॉल्व किए, जो कॉन्सेप्चुअल स्लोप डिफ्लेक्शन मेथड का एडवांस वर्जन था। उसके बाद हमने इन्फ्लुएंस लाइन्स पढ़ा, इन्फ्लुएंस लाइन फॉर डिटर्मिनेट स्ट्रक्चर, इन्फ्लुएंस लाइन फॉर इनडिटर्मिनेट स्ट्रक्चर, वाई इन्फ्लुएंस लाइन इज इम्पोर्टेंट। सारी चीज़ें हमने पढ़ी है, जो आपको नेक्स्ट सब्जेक्ट्स में कहीं ना कहीं यूज़फुल होने वाली है, राइट। तो इसी के साथ ही हम यहाँ पे हमारा सिलेबस कंप्लीट करते हैं। आपको यहाँ तक अगर कुछ भी डाउट हो, you can contact me anytime, right? As you know, SA2 is the most important for us. Okay, so thank you very much. कभी भी कुछ भी डाउट हो आप मुझे कांटेक्ट कर सकते हो। Till then, thank you.